Okay, well, good evening, everybody, and welcome to an evening with Iain Allen, who is a member of the Guild Virtual Events team, as well as being one of our video managers for YouTube and also for all the recordings that go on at our live shows. Iain has been using CAD programs since 2020, culminating in his design of various parts for locomotive projects. And if anyone has specific requests, please let us know via chat so that Iain can cover those. So welcome, Iain. Thank you for joining us, and I'll hand over to you.
Thank you, Jackie. Good evening, everybody, or good afternoon, or good morning to wherever you are in the world. Just a quick warning, I have had a message come up a couple of times saying my internet is unstable. So fingers crossed, everything's going to be okay. I think it's basically because I've got Fusion 360 running in the background at the moment, and that just eats data on the laptop. So the idea behind this session tonight is I want to take you through some basic CAD design, just to show you what you need to do working from drawings and then transferring that or adding to it to make sure that you get a successful 3D print, and also to look at how we go from having a 3D print made to a wax made with a mold and then producing a cast brass finished product from that. I'm going to start with a chimney, effectively, just very simply. So this is a 3D print, which isn't focusing very well, but that's 3D print we're going to be looking at. And I'm going to basically start off, but Jackie, can you enable screen sharing, please?
Yep.
Look at Fusion 360. And I'm also going to bring up at the same time, because I need to stop sharing. Sorry, apologies, bear with. This is a works drawing of the Lancashire Yorkshire, one of the Lancashire Yorkshire chimneys. Now, I don't have a drawing for the actual A-class locomotive that I've been working on. There isn't one in existence. So this is the drawing for the Lancashire Yorkshire 242, which is similar in dimensions, and I've used it so that I can take dimensions off this drawing and bring them into Fusion and then adapt it for the A-class, because I know the height of the top of the chimney above the top of the smoke box. It's just an adaptation. The first thing I want to do is to zoom in so you can all see that the width of the material for the chimney is actually 1/4 of an inch in 12 inches to the foot, and that's basically the material that we use for drawing the chimney itself. We've also got the top of the chimney with its lips, and as you can see here, there is actually a recess, there is an opening, and I'm going to go through that with the Fusion 360 drawing as well, because it's important to understand that sometimes what you want to try and replicate in a 3D drawing doesn't actually work when you try to do a 3D print. So this is what I'm going to be looking at working from. So I'm just going to stop sharing that screen and go back to Fusion 360. So here we are. We have the start of a drawing for said chimney. I've got basically the outline, as you can see, and if I zoom in, that dimension is 0.5 millimeters. And this is just a starting point. So we've got our diameter of the thickness of the wall at 0.25 mil, which equates to a 1/4 of an inch. And I've designed it so you can see I've replicated this shape that we just briefly saw on the drawing a minute or two ago. So taking from this, we then do an extrude and produce a body. Now, this is all very well and good to start off with, and this is where we need to take into account what we can and can't produce in a drawing for our 3D print, and also it has knock-on effects for what our 3D master and our brass casting is going to be. So under here, we obviously have a hollow and a lip. So trying to do that as a 3D print shouldn't be too difficult a job, because all that would mean is that when it's being printed, it needs to be inverted so that any of the resin that accumulates during the process of doing the 3D print can drain out. If it's done this way around, then this area here can act as a little reservoir all the way with a ring, which means it may not produce a good render of the item that we're trying to have manufactured. So that is one thing we need to take into account. So what I'm going to do, I'm going to quickly just get rid of the body again, and I'm going to edit this sketch, and I'm going to draw a line from there to the midpoint. And now that's all blocked in. Don't worry too much about this excess here, because I'll come back to that. So if I now do a finish sketch and redo the body, it doesn't work because I've made a modification. So what we do now is I'm going to go back to another edit, and I'm going to remove all these additional lines that we don't need. One, because they make manufacturing difficult, and two, you won't actually see them either when on the finished product or the finished model. And now if I finish sketch, we now have a new body. So this body, as you can see, has still got the very thin wall, as we were expecting of the prototype, but now at the top, it's filled in. We don't have that horrible lip all the way around. Now, if this was going to be something that we could manufacture out of brass sheet, for example, excluding the top where the lips are, that 0.25 millimeter material won't be too much of an issue. You can replicate that quite easily. It's a very thin material. But to 3D print 0.25 mil, don't forget at the moment that this is working off a non-scaled drawing. So this is just a change of dimensions in terms of, instead of it being 1/4 of an inch, it's 1/4 of a millimeter. But what we're going to have to do, of course, is scale that down for 7 millimeter the foot, which means 0.25 divided by 12 times 7. So we still don't have a very large wall to work with for a print. So just a quick bit of maths, 0.25 divided by 12 times 7 gives us one. Oh no, sorry, that's gone wrong. Apologies. 0.25 divided by 12, because the 2 didn't work, times 7 equals 0.146 millimeter as a wall for 3D print. I've been advised by Mick Davies, who I now go to do all my 3D printing, that 0.5 millimeter is an ideal minimum to work from. You can go lower, but you can't necessarily guarantee consistency in the print. So we look at 0.5 as an ideal compromise to give us a good quality print with good thick walls that are going to stay robust and not be too fragile and not damage or break too easily. So what we have to do then with our chimney effectively is to add extra weight to the body, extra mass to the body. So I'm now going to get rid of that body again, and I'm going to add this sketch. So what I've done now is I've added, with a previous drawing, another 0.5 millimeters to the actual drawing that we're going to use as a 3D print. Going down to the bottom here, we can see we've got a little gap somewhere. Hence this bit in the middle is white. So I'm going to delete that little tag. I'm also going to delete all these sections up here that I don't need. And now I'm going to draw a new line, because we need an actual full length line to complete the area of the body. You can see now that's gone to a shaded blue. Finish sketch and add the other sketch again. So with these two shaded blue areas, I can now select them both and do an extrusion. Now I'm doing a round extrusion, a circular extrusion. So I'm selecting the revolve tool. This brings up two profiles selected. The axis is the center line. New body, press OK. Now we have a chimney with a thicker wall, which means it should make a much better 3D print. However, going back to the original drawing, there is an additional slight taper on the inside wall. So I've also made another drawing here. And with this one, I can now select that one and do an additional revolve along the same axis. I'm going to make it as a new body, because now we can do a modification, change the appearance. If it comes up, where's it gone? There we go. We make the outer part of the chimney red and the inner part of the chimney blue. And that means that when I get rid of that box, you can now see where two parts join effectively at the top. So it just basically coming to a very, very fine point. It's very, very fine taper. So this is our basic chimney design for the main body of the chimney. So that's what we have to consider, like I say, in terms of wall thickness. So what we've got at the bottom here is 0.5, 0.5 and 0.541. So we're looking at 1.541 millimeter for the bottom of the chimney and 1 millimeter across the top of the chimney. And that is basically just so that inside we get in a slightly thicker wall as it tapers to the bottom, because obviously at the bottom here we've got to do all the part of the chimney that rotate, that flows around the smoke box and has the fillets. All with me so far?
I've got a question here for you.
Yeah, carry on.
Ray. Iain, as you go through this, would you please tell us if a PLA printer would be able to do this? Most videos suggest that resin is better for detail, but I don't have resin.
I've seen some work that's been done on PLA printers that actually is very good. The advantage with FLP stroke resin printers is you do get a lot more detail. The problem with PLA is I doubt you could get a very nice casting from them, because the layers on a PLA are a lot more obvious than they are on a resin print, just because of the way the PLA works, unfortunately. So if you're looking at having something that you want to have cast, then I would, if you've got a drawing that you've done in 3D CAD, I would look at getting a 3D print done commercially, to be honest. I mean, I think I paid £4 for having one of these chimneys done as a resin master, and you don't have the issue of having to do any cleanup or all the other messing about you might need to do. I've not really ever worked with PLA printers. A couple of friends have, and they use them quite a lot, but the build lines are a little bit more obvious, to be honest. So you would have a lot more cleaning up to do to reduce the build lines before you went to the casting stage, unfortunately. Okay, so this is our chimney that I've got it so far. What I'm going to do, I'm going to now open the actual chimney that, or the drawing for the chimney that was actually produced. So this is how it has turned out. You can see it's got our 1mm thick wall at the top, and at the bottom we've got the 1.541mm thick wall. There's a taper through the chimney because the reason to make it thicker is at the bottom here, of course, this is where it's most fragile in terms of being made, because you're actually adding other parts to it, and you want to maintain quite a thick area at the bottom, because even on the brass casting, that's where it's going to be inserted into the smoke box. Okay, so this is our 3D print master. And from this, like I say, what I did was the way I work is I take dimensions of the drawing of the product of the item that I want to have made, just convert the inches into millimeters, and then scale down from that drawing to do a working 7mm 3D print. But what you've got to also do is take into account shrinkage. So brass and nickel silver casting processes end up with shrinkage of the material as it cools. So once you've done a 3D render of your item, you've then got to add back the shrinkage rate. So if we just look at this drawing as we have it now as being the 100% sized item that we want, for brass, I would normally take that up to 101%. So you're giving an extra 1% in size so that when it is cast, the brass, when it cools, ends up at the same size as a 3D print of this drawing would do. Okay, I'll go through that again. If this particular render at the present you can see on the screen is our working 3D drawing that a 3D print is going to be produced from, then it needs to be 1% larger so that the brass that we're going to be using for casting, when it shrinks, will end up being the same size as the 3D print was when it was first made. Okay. I'm going to stop sharing. So now we've looked at that quick 3D print and a quick bit of drawing and what you have to take into account in terms of making sure that the wall thicknesses are thick enough to allow a 3D print to succeed. Like I said before, you get a very nice product. So 3D print of a chimney. Moves me down the bore. In fact, if I get my phone. See down this, so you can see down the bore there. You can see the chimney. Hopefully, if it'll focus. Not very well with the new webcam. And you should be able to make out the lip at the bottom as well that we have. What I will do is I will put photographs of these up on the Guild website as well, and I might be able to drop some into the recording that we're doing at the moment. Now, the next stage from having the chimney 3D printed, once again by my friend Mick Davies. Mick works as part of the Finney 7 team. So you can see the Finney 7 team at a show. Mick is the large guy, normally wears a white t-shirt. So if you want to talk about 3D printing, he's the man to speak to. Okay. This will then go to a caster, and I've used Iain Young from Sans Pareil ICS, who's in Carlisle, and he's printed quite a few. He's cast quite a few nice items for me. What he does is he produces a mold. Here we are. So this, Iain sent this back to me because this is specific to something I want to talk about, which we discussed during the quick drawing. So silicon mold, which as you can see has got lots of like jagged edges, and that's where it's been cut open. And it basically, if anyone's seen Iain's session from last year, you'll be familiar with this. So basically this just comes apart and, well, actually, let's put it back together because there's a hole at the bottom. So this goes into a wax injector. So first of all, the first thing it does is evacuate any air from within the pocket, and then it injects wax into the vacuum space. And what we end up with, the other way around, is a nice wax. Okay, you can all see that okay? And the wax, just very, very carefully, comes out of the mold and has a plug in through the center. Now, I asked Ian to send this one back to me because when we first went through the design of the chimney, there was a little problem. And there you can see the little problem. So this was the problem of having the chimney walls too thin, in that the wax wouldn't penetrate deep enough into the mold, because even though it's going in under pressure, it's going in at a temperature, and as it goes in, it starts to cool. But what you're trying to do with your design is make sure that the wax goes all the way down into the hole of the chimney. Now I'm going to very gently extract this. That was quick. So you can see a nice wax with a big hole in it. Okay, so that's why we need to consider how thick the walls of the item need to be if you're going to have something cast. So not only has that wax failed, but it would also mean that, of course, you can't produce any masters from it. You can't produce any cast items from it. So this is why, like I say, I want to reiterate to people, when you're designing anything that you're thinking of having made or cast in brass, that the wall thickness is large enough. And just to show you, I'm going to stick the chimney back into the mold so you can see that that is where it came from.
Ian, can I ask a couple of
Yes,
questions?
of course.
We can just go back to the printing process.
Yeah.
Did you need support on the chimney for the printing?
No, I basically send my 3D files to Mick. Mick then manipulates them in Chitubox, I think is the software package he uses. Because, excuse me, just to wet my whistle. Mick has been doing printing for so long now and has got so good at it, certainly with the two print machines he uses. He knows how to orientate the item that needs to be printed to get the best results. So I just leave Mick to just get on with it. Say he uses Chitterbox, that will then automatically add supports for 3D print. But I think what Mick does, he also makes sure it orientates so that any supports are on an area that aren't visible on the final print. So for these, to be honest, when I received them, I couldn't even see where they were. I think he actually used the rim. He used the top rim, the top lip of the chimney for the supports. So the whole thing was done, inverted. So it would be standing on the supports, and the chimney would be upside down, being produced. But let's say, because I've not done any 3D printing for myself yet, I haven't got through into using Chitterbox or there's another slicer package. I can't remember what it's called. Dr. Nishaw, who's with us, might know. But there's 2 or 3 slicer packages for 3D printing, one of which I say is Chitterbox. I can't remember the name of the other one that's well used by people. Is that okay?
Thank you. And Ray said thank you very much because he hadn't thought about going out to commercial printing. So
Yeah.
if it's not something you do on a regular basis with resin, that's certainly something for people to think about.
Yeah, and like I say, if you're at any shows at the Finney Seven stand is at, go and speak to Mick because he's more than happy to do work for people. His rates aren't massively expensive, and he does some really good quality stuff. In fact, I've got more parts here that I'm going to show you that we're going to look at, so you can see that the quality is good. Going back to the
Just
failed.
stop for 1 second. There's
Yeah.
two slicer packages being put up for us: Lychee and
That's it, Lychee. Yes,
and
that's the one.
Cura. So
Yeah,
Rob,
Lychee was the one I couldn't remember.
Yeah, Rob Pullen mentioned lychee and James has said Ancura.
Thank you, Rob. Thank you, James. But going back to the Wax Master, here's one that's certainly failed. Very bad. Big,
Nice
big
for
hole.
Sundays.
Yeah, that's not very good wax at all. So like I said, this is why it's important you make sure that when you're looking at having parts 3D printed to be made into waxes, that the wall of the material is thick enough. I'm going to go back to Fusion 360 again, if that's okay. Just going to close these two down. And open up another item that I've had 3D printed. Well, we're going to look at a couple of items. So this is a motion bracket for the Lancashire and Yorkshire A-class that we're just going to quickly have a look at. While my laptop makes a lot of noise as the fan kicks in, because Fusion, like I said, Fusion takes up quite a lot of processing power. But can you all still see me in the little box while we're waiting for this?
Yes, we can.
Yeah. So there's a motion bracket that's 3D printed. Is it going to do this? There we go. So this is a 3D drawing for this item. Now what I've done with this is the same as I've done with the chimney, to be honest, in that we had to thicken this up quite a bit. So these tabs here are, I can't see because zoom's in the way, 0.75 millimeter, I think, off memory, or maybe 0.875. Can't see because, like I said, Fusion's at the bottom of my screen in the way. But as you can see, what I've had to do with the wall, I've had to make it a little bit wider. And the problem we were having was with the first 3D prints of this particular motion bracket, it was ending up bent. So rather than having a nice straight motion bracket, we had, and this is exaggerating, we had a bit of a banana. So it was bending in this plane, the first one. The second one that I had printed by Mick still had a banana in it, but not as much, because I increased the size to, I think, 1 millimeter. But going up to 1.34 millimeters thickness across that width there, as you can see from the blue line, meant that it stayed straight, pretty much. The other problem we had to look at as well was, you can see it on here, if I can get it to see, you see I don't know if it's better if it's further away, see the parts that are sticking up, that are pointing upwards, they're the supports for the slide bar brackets. Well, they are for the slide bars, sorry, and they were what were causing the bending. So what was happening was the print was bending. See if we can get the right way around, like this. See if we do it without snapping, because these areas where the slide bars sit, because there's more mass, they were causing the whole thing to shrink in a little bit, which is why we had to go to a slightly thicker item. So that's another example. Although it's not very thick, it's not a very large piece, you still have to take into account that possibility of something going a banana shape or having a bend in it. Just going back to Fusion again. So you can see there's quite a bit of mass here, relatively speaking, that isn't on the other side to balance it. It's all about how items are balanced in terms of when they're being produced. If these were protruding on the other side as well to the same extent, they'd probably even out and would stay straight with the thinner profile. But like I said, with this, I had to make it a little bit thicker just to maintain a straight casting when it was actually produced. The other one to look at, which is quite an interesting one as well, which also made me have to start thinking about how thick the material had to be, was having some front sandbox stroke driving wheel splashers cast or printed as well. So these are the same Lancashire and Yorkshire A class, and I'm just going to show you the rear of the item. On the actual locomotive, once again, this material is only about a quarter of an inch material. I think these are actually cast iron on the original locos from the 1880s, but they could get away with having a thinner material than retrospectively compared to what we need to do with our prototypes, because we're using different technologies, different techniques, and have to make sure that it doesn't just collapse on us when we pick it up. So the walls of the sandbox and the splasher have had to be thickened up as well, and you can see here on the real thing, sorry, interjecting, there is a division here, because this is the sandbox part, division there for the sandbox, and it goes vertical. So this curve only goes through this part of the body of the item, and then you've got the diagonal and then a vertical part for the sandbox. But we can do away with that. We don't need it. It's not necessary. We don't see it, and we're not putting sand in because we don't need to put sand on all models. But I've also had to thicken up, click it right, this area here as well, to make sure that the front of the sandbox, when we actually see it on the locomotive, also is thick enough to be able to 3D print and cast. So there's exactly the same process with this as I used with the chimney to make sure that the walls of each part of this sandbox splasher are thick enough. The 2 feet as well, which are used for the rivets or the locating bolts on the footplate, have also had to be thickened up to make a 3D print as well. And this is one that, oh, you can't see it, sorry, stop share again. This is an example that Mick did for me. So that's a nice, I don't know why it's so grainy. More light in here. Still not better, is it? Hope you can see that okay.
That's fine.
Yeah, you can see the wall there with the curves that I put on it. So with a 3D print, the first one of these, if we'd have gone with the standard dimensions on the works drawing and tried to replicate it as a 3D print, then this would have failed as well, just like the wax did for the chimney. In fact, I think one of the first ones that I had back from Mick before I went to the thicker walls, that area actually bent. There was a bend in it. The top, funnily interesting enough, the top was fine, and the curve of the splasher was fine, but the front wall here, the front, effectively with the vertical panel, was bent in. So that was, and Mick didn't even expect that. Mick expected it to fail on the top or on the face of the sandbox splasher. So once we've got our waxes made, albeit without a hole, this then goes to be cast. And as probably many of you have seen from, if you've watched Iain Young's Evening With session, he goes through making how to make the waxes and how to manufacture. He puts trees to get what are called trees, where you put all the waxes on a central column spine as a tree, and then they go into a pot, which gets basically plaster of Paris poured in under pressure and evacuated, well, vacuum evacuated. They then get cured, and then the following day they're used for producing the brass masters. So his way of holding this. Here we have a chimney. I can get it to, you can see that okay. So nice and smooth. I don't get it further away. Just put it on my forehead. It looks nice and sharp then, isn't it? So that's a chimney that's cast by Iain, which I finished just basically just to polish up. But as you can see, it's quite good down the centre, nice and crisp. And there's very little in terms of cleaning up. Very, very nice castings from Iain. Going to the motion bracket. So I've got motion brackets as well. Included on this casting are two reversing shaft brackets as well, with all their detail. So these are the items made by Iain. You can see that's, hopefully you can see that's nice and straight. No bend in that. Another item that Iain has cast for me as well is a brake stretcher for brake hangers. So that obviously attaches to the bottom of the brake hangers and will have a rod through it. So that's a 3D print. Now this, interestingly, compared to things like the chimneys and the motion bracket, that is, that's worked out on the drawing. It should be 1 inch in height. The drawing was 1.34 mil, which scales down, and this is what we've actually been able to produce. And I think that's just over 0.5 millimeter thickness. So very fine in terms of what can be 3D printed. That was done by Mick. And then Mr. Young has managed to also cast it. And we have this. Which we could turn into a propeller. So you can actually get some very nice, fine castings produced. And Iain does actually brass casting for 2 millimeter items in brass, and some of them are just unbelievably small. So you can actually still produce very fine, exquisite items with this process and with this methodology. Going back to the splashes and sandboxes, we have these two items produced. So for the A class, which I'm looking to do in kit form for myself mainly, but possibility to produce, rather than having to make these out of three or four pieces of brass, they will be provided as castings, which makes life a lot easier and a lot simpler and a lot quicker. You don't have to worry about trying to align different pieces of material and try and do the reverse curve and such a sharp curve. Just because it's such a lovely quality, and to be honest, they're quite nice and fine in terms of how the wall thickness works out when you look at the prototype. But there are other items that I've got that I've thought, do I need to have it cast? So the dome, for example, for the A class, is going to stay as a 3D print because it's not in a place on the loco where it's going to be subject to possible damage, because if the chimney's out of brass, you've got the cab behind and this is halfway down, then it could quite easily stay as a 3D print. And what I've done, this is something that Mick Davis told me about. You use a bung. So as well as designing the dome, designed a bung, and the bung basically goes inside the dome, and that is, interference fit. It's not going to fall out. So what you do is this goes inside the boiler tube, glued up underneath, and then the dome goes on top and is glued to it, and it should never come off. Oh, that's a good question, Iain.
I was going to say, did you see they tell you were reading that question from Ian?
Yes, you can. Funnily enough, Dan Randall forwarded a question to me a couple of weeks ago, and he asked the same question. He was asking about the Soraya Tech castable resin. I've not had a chance to speak to Mick about it because he's been very busy with Finish 7 and he's also just been over to the USA for a while. You can use castable resins. So what you would do is you have a 3D print made of your item out of a castable resin, but you still have to take into account that shrinkage. So you'd have to add the 1% or 2% if it's nickel silver, for example, to allow for the shrinkage. That castable resin would then go to your caster, who would make the mold from it, and then off you go with your no, actually, sorry, no, step back a bit. If you were going to have one item produced, then yes, castable resin. If you wanted to have 10 or 15 items produced all the same, you've got to make sure that the castable resin on your machine can do the repeatability, because you would have to send all 10 items off to get 10 items in brass back. If you then needed another 5 or 10 items, you'd have to do 5 or 10 more prints out of castable resin and then send those off to be cast. Going the just one 3D print master and having a mold made means that there's your master. You never have to reproduce it. So you just use that for producing waxes, because they're all the same out of the same mold. But it's an interesting new development that people are looking at. I think the castable resins seem to be more in vogue and in favour with jewellery and the guys doing the wargaming type of stuff. But the kind of detail that we need for locomotive design or rolling stock items that we want producing, I still think possibly having a 3D print as a master and a silicon mold being done was possibly the best way to go about it. If you're interested in looking at that option, though, Ian, I would definitely phone Iain Young at Sanspari and chat to him about it, to see what his thoughts are. He's a professional; he'll know better than I, but I think he would still suggest possibly going down the 3D print that you use as a master from mold route. But the resins are improving all the time. Techniques are improving all the time. The technology behind the printers is improving all the time. So who's to say in a year or 2 years' time that actually we don't do 3D print to have molds made anymore? Everything's just done out of castable resin. I have had some items made out of castable resin, and I wasn't that enthralled with the quality. It was good, but when you put it under a loop, you could see all the build lines. So it's just something to consider at the moment. I said Dan Randall asked me the same question, and as he wasn't able to be here tonight, I answered it to him in a PM, a private message, private chat. Hence the video that I did as well for the rivets that he'd asked about. But so using just staying with 3D print for a dome, for example, is fine. You don't need to go down the cast route. For example, if that was to be cast, that's quite a substantial piece of 3D print to have cast. And because it's so tall and it's got such a decent diameter curve on it, this has actually got quite thick walls. And even Mick said to me, for this, you need thick walls at least a millimetre thick to make sure that the thing doesn't collapse. It's not necessarily just a case of, like I said, with the chimney, about getting the wax in the mould. In this instance, it's whether making sure the 3D print stays vertical, and also all the basic cylinder of the dome stays cylindrical and vertical. But it's got to go through that process of having a mold made from it and cast as well. But that's the other stage.
Got 3 comments for you.
Yeah,
Rob Pullum's told us that Mike Hopkins uses castable
he
resin
does. Yeah,
for the
yeah.
items that he has from Scale Factor. Nigel says, just a word of warning, Robin Taylor used a 3D printed dome that Nigel made for him for an NER 1001 class. and he damaged
Yeah.
it this week, so beware.
I'll say one thing. Well, that's Robin. The 3D, the items that Mike Hopkins did for me, there, when you look at them under a loop or a magnifier, you can see the build lines. They're from Wax Masters. So just horses for courses, Rob, as well, and for anybody else. By all means, try it. But I think it's you've got to look at what you want out of the product. These brackets in particular are going to go inside the frames of a locomotive, so they're not going to be that visible. So it doesn't really matter that the build lines are there. But for anything that's exterior and something that is obvious and quite large, like chimney, you don't want to see those build lines. I know that Mike has done some really nice stuff for Nick Dunhill in the past as well, but I think Nick has spent quite a bit of time in post-production cleaning them up to make them look rather nice. The other thing as well, to prove the concept of your 3D print, your scaling to allow for the shrinkage in the casting, is this particular chimney. There are actually three, but I haven't cleaned these up yet. This one in particular, I cleaned this one up because this is just a 3D print of the petticoat blast pipe that is under a chimney inside a smoke box. The bit at the top isn't prototypical. That's just because it's going to get glued to the inside of a smoke box. But this was designed at the same time as the chimney was designed in 3D CAD. The chimney was then scaled up to allow for the shrinkage of the brass when it was cast, and lo and behold, they go together. So if you get your scaling right and you get your dimensions right, there's nothing to stop you combining brass and your 3D print as well. Okay, so that will sit inside the smoke box. It wouldn't really ever be seen, but it means that you can, on the model, you'll be able to look down and see the bottom of the petticoat and the blast pipe, or certainly the petticoat. Obviously, the blast pipe is from the exhaust steam chest. Okay.
Okay, there's a couple of things from John Walker.
Yeah, hi, John.
He's tried the Soraya cast resin and the quality did not match the Soraya Fast Navy Grey.
Okay.
And also just mentions that Mike Hopkins uses a rather more expensive printer setup, Form Labs, he thinks.
Right. I know that Mick Davis swears by the Soraya Tech family of resins that he uses. And having seen his work and been his customer, I can attest to the quality of them. In terms of machines, it's okay having an expensive machine as long as you have managed to get the best out of it in terms of what you're printing. I'm sure Mike knows exactly what he's doing. Like I say, I've seen some stuff that he's done for Nick Dunhill and I think Warren Hayward as well in the past, and they were really very nice. But it's just with my experience with the the items he did for me. When I looked at them closely, I can see the build lines. For me, that's a bit of it's a bit off-putting, shall I say, more than anything. Because if you're going to go with something and you're thinking, right, I'm going to design a locomotive, I'm going to need 50 items out of cast brass. Do I go to scale factor where it's just using castable wax, or shall I go to Iain Young and get them cast the way Iain casts and have say this kind of quality where there aren't really any build, you can't see the build lines from anything that Mick's done in 3D print, and you're getting real nice finessed item, albeit like I say, it's going to be underneath the logo. It's going to be between the driving, well, not between the driving wheels, but behind the driving wheels effectively, and not really visible. But it's nice to know that you're getting something that is a quality item. This, for those familiar with modern outline kits, it's modern outline kit quality at the end of the day, and you can't say no to that if you know your kits and your kit manufacturers, and comparing castings from some kits, I'm not going to mention any names, compared to the castings you get from Finish 7 or MOK. Blue Cast X1 casting. Oh, that's one of the new casting waxes, isn't it? Blue Cast. I was looking at that earlier. That does look quite a nifty wax. Let's just look in the chat.
For anybody who hasn't got chat open, that's John Baker just saying, I've chatted with Mike before and he does use Formlabs. I've been experimenting with Blue Cast ×1 castable resin with some good results on an Anycube Mono 6K.
Right.
Castable resin's far more difficult to print with than normal resins, not insurmountable, but take quite a lot of experimenting to get it.
Yeah, I think, and that's the thing, isn't it, John, that you have to put the time aside to experiment and experiment and experiment until you find something that works for you. And like I said, a few minutes ago, the way the technology is moving with the printers, if you've got a 6K printer, obviously that's going to be higher resolution than a 4K printer. And certainly, the 8K printers that are coming online, I think somebody's even talking about a 12K printer. It's going to get to the point where can you actually see that? Much like with TVs, we've got 4K UHD TVs now. 8K UHD TVs are going to start coming out. Will you be able to see the resolution difference? I doubt it. It gets to the point where there's too much detail and people won't like it. We've gone through that whole process with broadcasting in the past in terms of resolution changes and technology changes, and having a broadcasting background, I know what the succinct line will be eventually. But it's all going to benefit us as modelers in terms of what you can do in terms of 3D prints and then going through casting. But I just wanted to make sure that those that were looking at doing that were aware that in your 3D drawing that you're going to do for your item, you've got to make sure that you get anything that's going to be, certainly something like a chimney, the wall thickness just right, so you're going to get a satisfactory and successful 3D print, wax and cast brass item.
Ian, you were just talking about Soraya.
Yeah.
The question from Dan Randful for everybody's benefit was that he's currently working on some projects in Fusion 360. He plans to have cast in lost wax brass. Can he get away with using ordinary IPA type, a non-water soluble ABS-like resin, or does he need to splash out on some Soraya Tech castable resin?
Either Soraya Tech family for getting a 3D print done as a master to have a mold made, to do the 3D casting that way, or to go with one of the options that was it John Baker mentioned, wasn't it, with the Blue Tech family, was it? Yeah, the Blue Cast X1 castable resin, which is one of the new ones. I think from memory, that is, John, is that the one that starts off as a nice deep blue and fades? I think I was reading up on those earlier.
Yeah, it starts. It comes out as a almost black. It's like a dark green, and then as it cures, most resins will cure with UV light. This one is a chemical reaction. You cure it with ethanol or ethyl alcohol, should I say? And as it cures, it changes color, which is really handy because you can see when it's cured.
Yeah,
which is important if you're going to cast it, because if it's not fully cured, it doesn't burn out properly, and you get ash and really poor surface quality.
Yeah, that's right. Yeah, the ash then doesn't go anywhere, does it? It just sits there and ruins your casting.
It just sits there, and
yeah. Thank you for that. Appreciate that. That's really good to know. But quickly before we go, some other items. Where are they? Another item that I've had 3D printed. Not one, two actually, but left and right hand. So this is a brake hanger for a LMS 8F that I've had 3D printed by Mick, and this is its twin because they are handed. So that had to be made thicker across the profile on the vertical. Sorry, a little there. That had to obviously be made a bit thicker than scale, because otherwise the 3D print would have probably just about made it, but the 3D casting wouldn't, because it comes back to wall thickness again. But here we go. I can get on. So there's a nice brass casting again from Mr. Young. That's the problem with the shiny. Can't see them very well. And they wobble. Okay. It's all about making sure, like I said, that and reiterating that to get away from any failures, you've got to have that understanding that you can't always scale from a drawing exactly. You've also got, there's this compromise if you have to make things a little bit chunkier. And as long as you're over that, around that 0.5 millimeter minimum for your 3D print, then you should pretty much get successful brass castings. When I was talking to Iain Young before I went down this processing route, he was quite happy for things to be about 0.3, 0.35 millimeter, I think, from memory. But it all came down again to making sure that 3D print is robust enough to actually produce a good print to then be able to use for your master to get the castings made from. And that, as I said, talking to Mick Davis, he didn't want to go below 0.5 or suggested I don't go below 0.5. And as Mick has done design work for the Finish 7 team, I took his guidance on board quite quickly, because obviously he knows what he's doing. And with the anyway, if you following Western Thunder, will see what he does on Western Thunder, which is just, some of this works fantastic in 3D printing, but also for doing 3D prints that are going to be used for castings for the certainly 3 new locos that are coming out from Finish 7 that have been recently mentioned by Richard Lambert. So if, like I said, if you want to talk 3D printing and get some advice about getting some work done commercially, Mick Davis is your man as far as I'm concerned. And, Rob's used Mike Hopkins and is quite happy with him. So, that's fine. But I think I've covered everything I need to cover for this session. Is there anything anybody else wants to know or ask, then please do.
I think that Mike Hopkins has stopped trading, to be honest.
Has he?
Yeah, I think so. Yeah, he seems to have sort of pretty much disappeared off the scene. So
because he only did one Gildex, didn't he?
Yeah.
He had a stand at one Gildex, and then we didn't see him again.
I think if he is still working, he's not doing it as commercially as he was doing. So
right.
I think that was for personal reasons. Iain, can I take you back to the beginning? Because what you showed us in Fusion 360 was a nice works drawing. How do you source those drawings for the uninitiated?
Okay.
What sort of sources do you have for finding the drawing of an item that you would like?
Okay. Ding, 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 ding. I've invariably used, for most of the work that I've done, the National Railway Museum. Their archive is brilliant, although there are large holes in certain drawing collections, and that's not the fault of the NRM, that's the fault of the railway companies, in that drawings were basically thrown away, they were skipped. A lot of drawings were actually saved from skips, and I know in terms of the LMS drawings from the pre-grouping companies, nobody's 100% sure, but there was a fire at Derby Works in 1951, and it wasn't in the drawing office itself, but apparently a lot of drawings were destroyed in the fire, even though it wasn't in the drawing office. I think the fire was in some of the other offices that had nothing to do with the the design of locomotives or rolling stock. It was admin offices. So there are gaps, unfortunately. But basically, for something like for the A class, Lancashire Yorkshire A class, I've just been to the NRM and made a booking there for what's the archive called now? I call it something, don't they? Search engine. And just basically been along and photographed what I want for the A class. So these are all the folders with all the photographs in of drawings that I've taken over a number of years. So it doesn't cost anything. It's not difficult to do. You just go on the NRM website, go to the menu for research and archive, I think it is, and then in the drop-down menu there's a section that says drawing collection. You click on that and you scroll down that page, and then it comes up with a section that's got like A to E, F to J. Click on those, open them up, and it'll show you the works that it's pertaining to. So under A to E, you would have Ashford, for example, on the southern region, Bow Works, Derby Works, Crew Works. Under F to J, you'd have Horwich. Under P to W, you'd have Swindon drawings, for example. There's a separate section for the BR standards, so that's where I've gone mainly. Recently, though, as part of being a member of St Neots Model Railway Club and being ganged into helping with the Bowwaters layout that has just recently been on exhibition tour, we've sourced some drawings, or will be sourcing drawings, from Staffordshire County Records Office, or Staffordshire Record Office, because they hold the archive for W.G. Bagnall, and Bowwaters Paper Mill in Kent, along at Kemsley, had a number of locomotives from W.G. Bagnall. So hopefully we've got 42 or 43 drawings that we've shortlisted that they're going to reproduce for us, and we can then start looking at designing some narrow gauge locomotives, 16.5. So there are other options. Glasgow, I can't remember if it's Glasgow University Library or one of the other main libraries in Glasgow holds the records for the North British locomotive company. We built many hundreds of locomotive designs, not just for British Railways, but for overseas railways as well. Manchester Records Office, I think, holds the Bay of Peacock, or I think they hold the Bay of Peacock works drawings records. They certainly have a lot of Lancashire and Yorkshire drawings as well at the Manchester Records Office. So local records offices can actually be quite helpful in some respects, because some companies, their records, that's where they ended up being.
Russell's just mentioned that he understands the NRM's online drawing service is currently paused while the post is refilled. When I contacted them recently, they had no timescale when the service would resume. Would it be possible to visit and order on the spot?
It would be better if you knew which drawings you wanted, Russell. It would be better to find them from the NRM's online listings and arrange a visit and arrange for those drawings to be brought up in advance. If you turn up on the day, they don't have any time to actually source drawings on the spot for you, because there are only normally 2 or 3 archivists on duty on the day. The main 2 are Susan Staples and Peter Thorpe. Christopher Lynan is the chap that is currently going through the whole, in theory, going through the whole of the drawings that they've got and scanning them. But I'm not sure what's happening in terms of ordering online at the moment, because I would have thought if there's something you wanted, then it would have been Chris that would have been doing the scanning. So whether Chris has left or not, I don't know. Maybe I need to drop Peter Thorpe or Susan Staples an email and see if Chris is still there. But one time I was there last year, I was chatting to Peter. He said they are understaffed. They haven't got the funding to look after the archive. They haven't got the funding to bring the archive up to date. They actually have the Charles Roberts Wagon Works drawing archive, 800 boxes, and they haven't got any time to catalogue it because they haven't got enough staff. So there is a whole archive that is not catalogued and probably never will be catalogued. And that's where I feel the NRM is going in the wrong direction, but that's a story for another night in a different table and a different forum. But I'd suggest phoning them up, Russell, and seeing what they say. Yes, yes, that's quite right, Russell. Order in advance.
Thanks,
but
Iain. Yeah.
that's what I do, mate. That's what I do all the time. And I mean, normally you are restricted to. They normally say 9 items, but I've been going so long now. They say, and I order 9 rolls at a time. So from the Orich archive, I'll say I'll order roll 96, 98, 101, 104, 120, 121, 131, and they just bring the whole rolls up for me, and I just go through what I want and cherry pick the items that I'm looking for at that particular time.
Yeah. That's
They're
very good to
quite
know, actually.
accommodating.
Yeah, it's very good to know because at the moment I've been wading through their Darlington drawings to get particular drawings
Yeah.
ordered. And just to get half a dozen drawings ordered, it costs a small fortune and it
Yes.
takes months. And now they can't do that. So if I could visit York for a day and tell them in advance what roles I want to see, that sounds really good.
Yeah, it is.
Just the problem is, could you be able to get those done on the day? Could you photograph them yourself? Because the ones I've had done before are original drawings, obviously probably AO size or even bigger, and they've had to send them out to contractors to make them into TIFFs.
Yes,
which obviously that's the cost. So
well, they used to send them to York University to get
Uh-huh.
to get the scans done. So if you had an AO drawing that was scanned, it went out to York
Right.
University. They now have their own scanner on site.
Oh, okay, that's good to know.
Yeah, because basically what happened was they'd sent a lot of drawings out to York Uni for scanning. I don't know how many boxes were involved, but they all came back mixed up.
Oh.
And they haven't had, and that's another example, mainly affecting BR standards. That's another example where they physically haven't had the time to go through the boxes to sort the boxes out and the material that's in them. It was just getting stupid. So yeah, I mean, I've been and come away with drawings for 100. I've been and come away with photographs of 100 drawings from one day's visit.
Brilliant. That
Yeah,
sounds
you'll
really
have
good.
more than enough time. And if you're going into search engine and you're doing drawings, if you go Wednesday or Thursday, it's normally quieter.
Okay,
I've
thanks for
been
that
in there. And
advice.
I've been the only person in there doing any work in the you have there's basically a glassed off walled room where you with
That's right.
drawings
Yeah.
and stuff. Yeah, I've been in there and been the only person in there. So yeah, do it.
Okay.
Definitely worth doing it.
Thanks very much.
Ian Haynes says it's easy to photograph them yourself, and John Baker says you can photograph the drawings with your phone. You just need to sign a disclaimer first saying that it's just for personal use and you're not going to sell them.
Yeah. Yeah, you don't have to fill paperwork.
That's
You don't have to
understood
fill
already.
paperwork in, but it's it's basically just
that's the usual thing you have to sign when you order them anyway. Online. That's fine, no problem. Great, thank you.
Oh, my pleasure.
Iain, you mentioned about 101% if you were casting in brass.
Yes.
What about nickel silver?
Well, the guideline is about 2%, but with all of these things, there is a caveat. It can depend upon the size of the item you're having cast. So I've actually done some of these some items at 101.5% just to test, and they came out right. So I think I remember, I can't remember if it was on Western Thunder or whether it was on Guild Forum where I put up the sandbox splashes. And after taking measurements, it was something like 0.07631, whatever, oversize. And we all thought that was quite interesting in that would you ever really bother with such a small number in terms of being oversized or being undersized? And I think they were done at 101.5. Now, Iain Young said to me, 1% for brass, not a problem. But if you're having quite a long item done that is quite thin, so for example, if you were thinking of having coupling rods done in brass, not that we'd ever do it in brass, but I'm just using this as an example, because they're long and thin, you would probably have to use a slightly higher scaling factor to allow them to shrink further because it's a much longer piece of brass. Items like these aren't going to be much of a problem with 1%. But I think a lot of it is just a case of, depending upon the size, a little bit of guesswork or just being a little bit circumspect and not being it hard and fast at 1%, because once your castings are done, it's very easy, if necessary, to adjust if you're doing coupling rods, for example, it's very easy afterwards to slightly adjust or amend the frame dimensions to match the coupling rods rather than trying to continually keep having castings made until they're right. And the other problem with items that are long and thin, is you can't always guarantee they're always going to shrink at the same rate. You might cast them one day and they're fine. 2 weeks later, they get cast, and because it's a different batch of brass, there's different, slight different percentages in the content of the brass in terms of it being made up into a piece of brass for casting. It might shrink slightly less, or it might shrink slightly more. Iain did tell me, and I think that comes out in his video that we did last year, his evening with, that there was a source of nickel silver that he had that just wasn't very good in terms of not just casting, but its shrinkage was terrible. And I think he now tries and sources his nickel silver from a company in the USA because he gets 100% success rate with it in terms of he knows how it's going to work. So there are variances. Nickel silver can be 2%, 2.5%, depending upon what you're doing. Brass normally around 1%, but you could go to 1.5 depending upon what it is. And it's all to do with volume of materials that you'd be using as well. So going back to the dome, you see, I would never do it. See that? It's still alive. I would never do a dome and have it solid because it's going to take so much brass for one, and when it cools, it's going to shrink, but it's going to pull the sides in. I think that's what you find with a lot of brass castings from the 80s and probably early 90s from molds that have been done where it's just used cast the whole thing in brass and there's no hollow, in that it sinks and it pulls in. You end up with this kind of like slightly wasted version of what you want. But once again, if you're thinking of having anything done, speak to Iain Young. He is the expert as far as I'm concerned. I wouldn't speak to anybody else about it because, one, I don't know anybody else, but the other people that are doing casting are mainly geared up for doing jewelry, which is a completely different kettle of fish to what we want, because we want the repeatability and want them all to be identical. Jewelry doesn't have to be identical.
Useful, thank you. Any more questions?
If there aren't any more questions, that's it. Everyone's happy. Hooray!
While people are having a think, I'll just mention what's happening next time. So if I just share screen, up to Zoom. Not coming up as slideshow for some reason.
Because you hadn't clicked on slideshow.
I have now. Spot the deliberate mistake. Okay, so everybody can see that?
Yes.
Brilliant. So next month, 27th of August, and I need to point that out, unfortunately, Philip Downs couldn't do the 26th, so we've moved to the 27th for 1 month only. So it'll be an evening with Philip Downs, who does radio control. And he's going to take us through various RC systems, their features, how they work, the hardware required, the battery types, and an overview of the installation in locomotives. And certainly more and more people are starting to look at remote control. It may be in the garden, it might be for other uses, but Philip is somebody who's seen as quite an expert on that. In terms of the other evening widths for the rest of this year, we've got on the 26th of September, John Neeshaw and Julian Best talking about train control systems. And then on the 26th of October, it's done Everson painting and weathering figures and buildings. And then on the 26th of November, am I right in thinking that it's Stephen Fay?
Yes.
And
I
he's
don't know why that's not on there.
Don't worry, it's my memory serves me right. It's Stephen Fay.
It is.
About dioramas. We've got a few people in the audience who aren't members of the guild. It's just to let you know that you can actually join online. You can also do a free 1-month trial, and you do get an awful lot out of the Gaujo Guild. Obviously, not just these sort of online seminars, but we do have the quarterly Gazette Guild News, which is a newsletter full of all sorts of things that are happening around the country. There's online shows and activities, face-to-face events, the forum, the website, and a lot more. So it is worth considering for anybody who's interested in No Gauge who may not be a member yet. And as you can see, there's a pointy arrow there to About Us on the Guild website. And it will actually say join online, and then there's a membership form. Very straightforward. In terms of YouTube channel, because all of these evenings are recorded, along with lots of other things like highlights of our face-to-face shows and lots of people doing various demonstrations and modeling techniques, the YouTube channel is really worth going on and looking at all the videos. You've heard Iain Young's session that he did about lost wax casting. Well worth putting some time in to look for that video on the YouTube channel. Iain, it might be worth putting a link to that within the video text when you do it, because it is one that goes hand in hand. And for anybody who's not used to Fusion 360, then certainly Iain's done sessions in the past about using Fusion 360. So the YouTube channel has a huge, that's the homepage, but then if you click on videos, there's absolutely loads and loads of them. It's free to subscribe to. The benefit of subscribing is that you will get alerts just telling you when we've added new videos. And as I say, the range is really worth looking at. It could be somebody's layout, it could be a modeling technique. Some of our traders have done videos about, manufacturing processes. So there's a wide range there to look at. The next show, in case you didn't know, is the 7th and 8th of September, our 2-day show at Guildex in Stafford. We've got Philip, who is doing the August evening is actually going to be there face-to-face talking about remote control as well. So if you actually watch the evening in August with him, you can then have a face-to-face chat with him up in Stafford. Likewise, obviously, Iain's going to be up in Stafford, probably with a camera in his hand, but it's well worth chatting to people face-to-face if you've got any further questions. And then our new winter show is in Wigan on the 7th of December. New venue, 2 big halls, and hopefully lots of goodies to buy for Christmas. So that's it from here. I will stop sharing for a moment and see if there's any more questions that have come up in the chat.
Just to go back to the Guild homepage, don't forget we've also linked on our homepage to our Instagram feed and our Facebook page.
Yes. Yep. So we've got Instagram, Facebook, and the forum, all shortcuts to them, and then subscribe to us on YouTube. You don't have to subscribe, but as I say, you will get alerts, and it does boost our figures as well. So it doesn't cost a penny. And if you do want to know about evening withs and all the past recordings, if you go to events and come all the way down the list to evening with, hopefully that's changed for you. There's tonight's session, previous sessions, all the way back. So you can actually find Iain Young's one there about lost wax casting on the website. Okay. Now I've got to figure out a way to stop sharing, because again, I've got all sorts of things in the way. There we go.
John says, a bit late in the presentation for me to mention this, but a company called Jewellery Casting Scotland can do excellent castings from 3D printed resins. I've used them before and the service and quality is excellent. Thank you for that, John. I might have to look into those as a possibility going forward.
That's the way to learn, isn't it? From
Yeah.
by sharing with each other. It's really, really helpful.
Hey, Nigel Payne, nice to see you, mate. Are you well? My pleasure. Hope you learned something from this.
That's Nigel Payne's in Slovakia. Anybody need to unmute and ask any final questions? No. Okay,
That's about
Iain,
it.
thank you
Thanks,
very,
mate.
very much. Really appreciate a very interesting evening. It's been so useful to understand the whole process, right back from the drawings through to the CAD work, and then obviously the resin print and the casting. So a good journey to learn from. Thank you very, very much.
My pleasure.
Thank you to everybody who's joined us. Enjoy the rest of your evening. And I hope that you actually join us again next month for the Philip Downs session on remote control. And we'll put reminders out just to say it is the 27th, not the 26th, for 1 month only. And lots of thank yous coming up there, Iain. Really good session. Thank you.
Thank you, everybody. Good night.
Good night, everybody. Thank you.